Now we'll talk about dividing rational expressions. We've got our division sign, so if P divided by Q is divided by another rational expression, you can see how division needs to change to multiplication of the reciprocal. So R now goes to the denominator, and our denominator S is now in the numerator. So some of you know this as the keep, change, flip technique. That means you keep your first rational expression, change division to multiplication, flip the second rational expression. And again, no matter what terms remain in your denominator, neither one of those can be equal to 0. Step 1, you want to recall. Rewrite the division problem as multiplication. Completely factor each numerator and denominator. Reduce any common factors that you find. And then use the rule to the left to keep, change, flip. So here we have an example of division, and it's also involving some multiplication. So the first thing we want to do is rewrite this in the proper form. We're going to have 5x squared minus 20 divided by 3x squared minus 12x stays the way it is. There's what we keep. Division will change to multiplication. So only this middle term, this middle rational expression, will flip. The last one does not flip. Why? Because multiplication is what precedes it. So we're keeping 9x cubed plus 6x squared divided by 2x squared minus 4x. It's only this middle rational expression that flips. So 2x squared minus 8x is now the numerator, and x cubed plus 2x squared becomes the denominator. Now we're ready to do a lot of factoring. In our first numerator, 5x squared minus 20, I can see that 5 is a common factor. So I'm going to start way over here, factoring out 5, and I'm left with x squared minus 4. Now, do you recognize x squared minus 4 is the difference of squares? So we really want to do x plus 2 times x minus 2. So I'm going to cross out x squared minus 4 in the middle. 2x squared minus 8x. It looks like 2 and 8 would have a common factor of 2, and there's also a variable of x. So I'm starting with 2x as a common factor, and that would leave x minus 4 in the quantity. Our last rational expression looks like greatest common factor is used again. 9 and 6 have 3 in common, and both terms have some amount of x. Compare exponent of 3 with exponent of 2, so 2 would be the highest exponent in common. That would leave 3x plus 2 in the quantity. Every numerator has been factored. Now let's go through the process in the denominator. 3x squared minus 12x. 3 and 12 have 3 in common, and they also have x in common. So I would have x minus 4 in the quantity remaining. In our second rational expression, there's not going to be a common coefficient, but they both do have at least x squared. That would leave x plus 2 in the quantity. Finally, our last denominator, 2x squared minus 4x, looks like they have at least 2x in common, and that would leave x minus 2 in the quantity. So now that everything is completely factored, I'm going to look in the numerator and denominator and reduce any common factors. So since my first factor is 5, I'm going to scan in the denominator. I've got 3x, 1x squared, 2x. There are no 5's there, so I'm going to keep 5. Then I have a quantity of x plus 2. It's kind of like playing Go Fish. So in the denominator, we're wondering if there are any quantities of x plus 2. So there is. One quantity of x plus 2 reduces with one other quantity of x plus 2. Look for a quantity of x minus 2. That doesn't match. That does match. So there is a quantity of x minus 2 in the numerator and denominator to reduce. Now I've got quantity x minus 4. I can see that I have an identical quantity in the denominator to reduce. Quantity 3x plus 2. I don't have any more quantities remaining in the denominator, so I cannot reduce that. But let's look at factor of 2. Factor of 2 reduces with factor of 2. Factor of 3 reduces with factor of 3. And then we do have several x's. Here's an x squared that reduces with x squared. Here's an x in the numerator with an x in the denominator. So now I'm going to highlight everything I haven't crossed out. 5 and quantity 3x plus 2. In the denominator, I just have that factor of x. So let's rewrite what we have. In the numerator, I have 5 times the quantity of 3x plus 2. In the denominator, I only have x. And I know that nobody's going to cross these x's out because this x is not a factor. It's an addend. 3x is added to 2. So there's no reducing possible there. This is the final answer. We've got one more example because you can't really practice this enough. X squared minus 8x plus 15, notice, is in a parenthesis all by itself. Do you recall that means the same thing is being divided by 1? Now that's going to help you to see this as a rational expression divided by another rational expression. So really what we have is x squared minus 8x plus 15 over 1 multiplied by the reciprocal of this given rational expression. So now x squared plus 6x plus 9 will be the numerator, and 2x squared minus 4x minus 30 is the denominator. Once you do the keep, change, and flip, you're ready to do all the factoring. Now this isn't quite as quick as greatest common factor. We have trinomials here, so either we're hoping we have some perfect square trinomials or we'll have to use sum and product. So x squared, that's a perfect square. Unfortunately 15 is not. So over here I'm going to go ahead and do sum and product for this trinomial. In the middle, negative 8 is the sum. Product comes from 1 times 15, so that's 15. I'm thinking 3 times 5 makes 15. How can we change 3 and 5 in order to get a sum that's negative? Make both of these factors negative. So negative 3 added to negative 5, that will make negative 8 for the sum. So we really have x squared minus 3x minus 5x plus 15. With grouping now, first group has x in common, leaving x minus 3. So the other group must have the common x minus 3. Working our way backwards then, how do we create minus 5x? With minus 5. So one factor is quantity x minus 3, the other is x minus 5. So going back to our rational expression form, I now can fill in quantity of x minus 3 and quantity x minus 5 over 1. X squared plus 6x plus 9. The first and the last terms are perfect squares this time, so we should be able to use our perfect square trinomial technique. So just think square roots. X squared is x times x. 9 comes from 3 times 3. And since the middle is positive, both of these quantities are positive. Now the last thing we need to work on is this denominator. So let's go up here and work on this. We've got 2x squared minus 4x minus 30. And all the coefficients are even. So if I pull out 2, I'm left with x squared minus 2x minus 15. So I can use the sum and product on this trinomial. Negative 2 is the sum, and our product, 1 times negative 15 would be minus 15. So it looks like 3 times 5 are needed. To make the negative sum, 5 needs to be the negative. So 3 times negative 5 matches our product, and 3 added to negative 5 will make the sum of negative 2. So we now have 2 times quantity x squared plus 3x minus 5x minus 15. We're ready to do the grouping on this, keeping 2. And remember, we have a lot of parenthesis sets in this one. Our first group will have x in common, leaving x plus 3. So x plus 3 will also be found in that second group. To fill in that gap, how do we match minus 5x? We need minus 5. So our factoring becomes 2 times the quantity of x plus 3, and the other quantity comes from x joining with minus 5. So our denominator, 2 times quantity x plus 3 times quantity x minus 5. Let's look for any common factors now to reduce. The first one I see is x minus 3, but I do not have x minus 3 in the denominator. X minus 5, we do have another common factor. Quantity x plus 3, that will match. Don't cross all of them out. Remember, it's a 1-to-1 relationship, not all of them. So whatever remains, quantity x minus 3, quantity x plus 3, 1 times 2 in the denominator. So it looks like our final rational expression is the quantity x minus 3 times quantity x plus 3, all divided by 1 times 2, which is 2. So remember that when you have division of rational expressions, you have to change division to multiplication, and the rational expression that comes after it will need to be flipped or inverted.